Morning, everybody. I have some good news. This is the last day, and I really hope that your shoes are still holding up. So hold in there. We got one more to go. I'm Simon Patenaude with CBC and Radio-Canada. I'm a senior technical advisor, and I'm here with my colleague Mathieu.
Yeah, I'm Mathieu Rachon, senior technical advisor for CBC Radio-Canada as well. And I hope you have a tiny space left in your brain with all these bombardment of new stuff that you saw in these last 2 days, because we have quite a lot to cover. So, Simon, let's tell the crowd what CBC's problems they are trying to solve.
Of course. So in Toronto, we have a building that was built in the 80s and 90s. And back in those days, we used to build very fixed studios and control rooms. And back in the day, we used to tie the control room to the studio. But we're in a technology refresh in this facility at the moment. And we kind of had a reflection as to, by the end of the project, we don't have a crystal ball as to what kind of productions that we're going to have to do. And so we wanted to go from fixed facilities, production facilities, to dynamic facilities that allow us to reconfigure studios, control rooms, and things like that on the fly, and not really build them for any particular use around news, radio, sports, or anything like that. And Mathieu, how does this actually apply to the rest of the country?
Yeah, so moving to flexible installation or flexible facilities, leveraging software and very centralized data center in both centers. We hope in the long term that it will help us to maintain all the broadcasts that we do across the country. We have a lot of stations. Canada is a really large country, and we hope to leverage the time zone difference to centralize all the processing of media into these two main centers that we have in Montreal and Toronto. What's CBC's vision about this new software world, Simon?
Well, this, like every good engineering project, it always starts off with a drawing. And when we started reflecting as to how we wanted to do this, we laid out our facility in layers. And at the very top layer here, you see our studio spaces. And like I was mentioning earlier, rather than labeling them radio studios or sports studios or news studios, we're calling them large, medium, and small, and self-op and hit areas. And really not necessarily meant for a specific purpose. Similar to our control rooms, then if we're doing that with our studios, we're thinking about the control rooms that we're thinking of large, medium, small, more about the space that's in there. But all of this is all the control spaces are interconnected with a universal GUI, and that's what our first target in all of this for the universality. And the thing with the universal GUI is it's not an exact replica for one, but we're going for familiarity so that if you're going from one mode to another, that you at least know where things are going to be. But all of this is supported by some infrastructure. And Mathieu?
Yeah, in order to achieve all that flexibility and dynamicness, we hope to, from the bottom up, use a generic compute stack and a generic network stack, either on-prem or in the cloud. And we're really looking for software-based application from multiple vendors to be able to flexibly, agilely create all our production workflows. And to reach what Simon was explaining about, like, okay, one day a control room is doing a small news show, and the next day could be a sporting event. All of these software function needs to be dynamically orchestrated to allow for fast reconfiguration for different production types. And in order to build that, last summer we released quite a massive tender. And Simon, what did we learn from that tender process?
Well, first off, we started writing the tender document again by starting with a drawing. And you can see here on the left is just a sample workflow, relatively small for what it is that we wanted to do. And in here, we identified about 30 functions that we needed. And we asked for this to be exchangeable through of media directly through memory to minimize the latency. We wanted the same software to be on-prem or in cloud, so no special differences between the two. And we wanted support for industry platform multi-vendor frameworks. And what we ended up getting is 12 vendors qualified to the minimum requirements, and we got 170 proposed functions proposed. But the multi-vendor platform support was practically non-existent. And what that really looks like is many vendors moving to software and new software-only companies that were starting up, which was very exciting for us. So there's a lot of momentum there. Vendors are offering flexible acquisitions models, so we can go to CapEx or OpEx based on what it is that you need. However, there was no single vendor that offered a complete solution end to end. So there was a lot of like Swiss Army knife solutions where they could do a lot of things, but not any one particular thing very well. So the biggest negative for us is there was no cross-vendor support existing for the proposed platforms and frameworks in our tender document. And somewhat of a positive, but somewhat of a negative at the same time was there's too many platform and framework options appearing to cause some hesitation amongst vendors, so they don't want to jump on the wrong thing at the wrong time. But with all this learning, we built a lab. And Mathieu, what did we learn from that?
Yeah, so looking with the response that we got, we also try to partner with some of them to do POCs. And one of the main challenge, as because it was one of the main requirement of our RFP, was to shared media through or exchange media through shared memory. And that's what we have tried to build in the lab in Montreal. And we just try to integrate two vendors to share media directly inside the same node through memory. And with the 6-month testing timeframe that we had, that proved to be unfeasible or unrealistically reachable. So we had to revert to an alternative solution, which was just looping in 2110 inside the box. It worked, but it failed to meet our latency targets that we had for that specific workflow. Looking at many other options, so far, we seems to be constrained by using streaming in between media function. The best of them for low latency and tier 1 production is ST2110. And it's not really efficient to connect application inside the same host or even across multiple hosts when you're running software. So, what are we doing, Simon, to accelerate the multi-vendor live production workflows and software?
So going with the stack drawing that we had from before, and using the tender document that was generated from there, we partnered very closely with the EBU, and the EBU has really been thinking about this for a long time on dynamic media facilities. By partnering with them, last fall, they released a dynamic media facility reference architecture. And in that document, there's a stack of 6 vertical layers and 6 horizontal layers and 3 vertical layers that cut across all of these. But there's a lot here to handle, and there's a lot of work there. So in the short term, we decided to focus specifically on that media exchange layer, which is where we want that media exchange, or the memory share. So again, looking at a different workflow, this one a little bit bigger. Here is a multi-camera workflow where the gray box represents the platform, and all the boxes inside are media functions, but the colors represent multiple vendors. So we want to have the best of breed video switchers, the best of breed mixers. We want the best of breed multi-views, and we want to be able to interconnect this with as little latency as possible without having to leave the platform and go back in. So if we were to take this drawing and then we will look at it in a different angle.
Yeah. So basically, we're looking at small containerized component. So these are your media apps and functions. As Simon said, from multiple vendors. distributable across multiple nodes for scale and resiliency, because obviously a broadcast center as big as a Toronto broadcast center won't fit into a single compute node. To enter this software world, we still would use traditional IP stream like SRT 2110, NDI, or whatever is available. But once inside a platform, we want the software component to exchange media directly through shared memory in an asynchronous fashion. There's no such thing as timing once you're inside a computer. It's pointless to try to packetize everything. It's just a waste of resources. And the use of shared memory rather than streaming also augment the capacity that you have with your compute power. Talking to some manufacturer, in some cases, in software, just senders and receiver can take up to 50% of the budget of the CPU that they're using. So getting rid of that will make this ecosystem a lot more performant. And to exchange media through memory across multiple nodes, we don't want to reinvent anything. We just want to use what's already used by high-performance compute and large language model learning, which is RDMA over a very strong network. So how can we accelerate this specific bit of media exchange, Simon?
So when we decided to focus on the media exchange layer, we realized that we can work together between end users and vendors to come up with a common media exchange SDK. And the idea here is that for it to be an open source shared library that can be used by software applications to share media, real-time media in memory. But so by working together, that's the idea, is that we want to be able that all the vendors, our best of breed switchers and mixers and things like that, work the same way and get into that media. So, Mathieu, what does that look like in more detail?
So if we look at the user requirement, we're not talking about a specific technical implementation here, but you would have an individual media function that would like to use a common SDK to exchange media through memory. So that SDK would need a simple API to create, remove, read, and write media into memory. Obviously, the common media buffer data model would be needed. So one application that writes video into memory needs to write it in the same way as another application that would read it. So we need some form of understanding and commonality there. And there was also in the small print a bunch of other information that would need to be stored into that memory in order to make these small chunk of media logically reassemble when they need to leave the platform. Using a shared memory abstraction layer could help us to leverage technology that already exists in the industry. It could also be more future-proof for when new technology arise to exchange memory through different node or across multiple node. And there's already technology existing in the cloud with in AWS with Elastic Fabric Adapter. Rookie V2 is already also a technique that can be used on-prem. And Simon, we don't want to reinvent the wheel, so we want to use as much or as many existing technology that has been proven in the IT industry. So can you talk a bit about that?
So by looking at even within the media industry, there's a lot of things that have been solved already. There's a lot of things it's an industry that's full of really smart people, and we've solved a lot of issues over time. So we don't want to have to go back and reinvent any of these things. We could just draw on that experience and draw on those techniques. So that middle layer here is really where we feel that it has the most potential to develop and work from. So this is where we want to do the open source software written by the media industry players. But the bottom layer, there's far much bigger industries than us that have solved much bigger problems than we have. So why work and reinvent or redo anything there, or just leverage on that experience? And one such example is actually Live Fabric. So if you stick around for a little bit longer, there's going to be a presentation specifically about that shared memory abstraction layer by City Riedel a little bit later on today. And Mathieu, who do we partner with?
So, with all these talks that we had with the EBU and the other broadcaster and user, we kind of also discussed with many manufacturer that were kind of already into that shared memory thing with their product. And in last November, there's a small group that was formed to just explore the idea if it would be possible to create such an SDK and how could it work? So all these logos that you see there, they've been working together for a couple of months now. And the SDK, or that small proof of concept of the SDK, is well underway, and it's being worked on right now. It's going to be open source and freely available for end user and application developers. And just before NAB, actually on Friday, we did release a press release for with the Linux Foundation to host the governance of this open source project. Hopefully, putting that up quickly so that anybody interested could start contributing and look at what it's going to look like. So thanks a lot for listening. And if you stick around, you'll have a much more technical presentation about what this SDK is about. Thank you very much, everyone.
Thanks, everybody.